So the OSI model came together at a time when a lot of networking was just, you got an IBM computer, you put it together an IBM network, and it only worked with other IBM stuff. You got an HP or a DEC or whatever it was back then, it wouldn't work. So what are you going to do? So some engineers got together, mostly from the telephone monopolies around the world, France, United States, wherever, and they started this OSI model. So they said, let's just start with the physical layer. And that's just the cable. So in Cat5, Cat6 cable with an RJ45 jack, that's the physical layer. Very boring, but very important. If that doesn't work, nothing else is going to work. Right above that is your data link. So you've got Ethernet usually, sometimes Wi-Fi. And in the case of Wi-Fi, the physical is the radio waves. But data link would be Ethernet or Wi-Fi these days. Historically, there's things like token ring that we don't really see anymore. Then there are cable modems, DOCUS, and a whole bunch of others. Some defunct, some still in active use. But generally, you see Ethernet or Wi-Fi. Network layer then has IP. Historically, there was also IPX, and that's totally unrelated to IP as we know it today. Usually we see IPv4, and of course we're going to IPv6 someday. But the trick with the data link is that there's part of the frames, as they call it. So network has packets, data link has frames. And those frames get stripped off when they go outside your network. So those frames contain my MAC address for my interface. When I ping your machine over the network, it never sees the MAC address that's on the data link inside my own network. That's stripped off and then it's transferred elsewhere. Of course, you can see the MAC address with IPv6, for example, because there's auto configuration that's based on the MAC address. So you might see it outside the network in that case. IPX also worked that way way back in the day. Again, nobody really uses it. I'm just rambling. Transport layer, this is like TCP or UDP, and its job is often about consistency and making a connection. So TCP creates certain guarantees that packets will arrive in order way back on the destination, and that they'll arrive at all. So there are ways if packet doesn't arrive, it'll try again. And of course, UDP doesn't make those same guarantees, but it's still kind of in this layer. Now things get a little more complicated. There's the session. Now, the session is supposed to be about authentication, authorization, and encryption, and we'll talk about where these actually lie in the OSI model and how that's kind of changed with time. And then the presentation layer is about encoding. So UTF-8 might be the presentation layer, or ASCII, or EBCDIC is an old encoding. And it could be compression as well. It's kind of about how you present the data in a certain format. And then finally, the application layer. So this would be like HTTP or FTP or Gopher, whatever. Now, some of you might have noticed an issue up here is that these are often implemented in software. These two are often implemented in software as well, but usually at the operating system kernel, so you don't have to worry about those so much. And then this is hardware down here. But these application is often up here. Now you might ask, should I be organizing my program so that session and presentation are handled at these layers and then application just does the strict application parts of it? You can. Do you need to? Not really. I have seen applications that do have this nice separation, and that's a perfectly valid way to do it, but there's no reason to tie programmers' hands to always be that way. So this should really be just a suggestion. So the way things have tended to go over time, just have the application layer. And there's also issues with the session layer. it has encryption. And really, we put encryption all over the place. So the application layer, we put it, SSL wraps around HTTP so that you're encrypted there. But there's IPsec, which kind of puts it in here. And there's MACsec, which means an encrypted Ethernet, really. And WPA also is encryption for Wi-Fi. And then quantum encryption, you could argue, is the physical layer. It's the actual bits being transferred around that's doing the encryption there. So that's, you could argue, is physical encryption. So putting it just at the session layer is really limiting what we can do throughout this whole stack. So we just toss that. Nobody cares. There's good reasons you might split that up, but you might not. And you can organize a program in many different ways. So that's the OSI model. It's still a very important model for what's going on down here. Because even when this is in software, it's in kernel, and this separation makes for a very nice design that everyone can kind of understand what each piece is doing. And then once you get up here, you're kind of on your own. So that's the OSI model, and that's kind of where it stands today. Thanks for watching.